Hi everyone. Today we're going to talk about measurements a little bit more, but this time we're going to do some calculations using different measurements. So first we're going to discuss exact numbers. Last time we were talking about measured numbers, and measured numbers come from experiments, and typically we're using a measuring tool such as a ruler, but exact numbers are numbers that have no uncertainty, so they do not affect significant figures. And last time we talked about how to determine the number of significant figures for a measured value, but with exact numbers we don't have to take into account significant figures. So for instance, an exact number is either part of a defined relationship between quantities. So for example, there are exactly 100 centimeters for every 1 meter. So both of those values are considered to be exact. Now, additionally, an exact number could be a number obtained by counting individual objects. So, for example, if we have 12 eggs, we would have counted the number of eggs, and therefore that would be an exact number. We can't have half of an egg or a quarter of an egg, for instance. All right, and then a reduced simple fraction is also considered an exact number. So when we were discussing temperature and we were converting from Fahrenheit to Celsius, we had to take into account the ratio of Fahrenheit degrees to Celsius degrees, and that was a ratio of 5 to 9. So that would also be considered an exact number. And again, all of these different types of exact numbers do not have significant figures associated with them. So if we use exact numbers in a calculation, so for example, let's say we were converting from centimeters to meters, then we don't have to take those numbers into account when we're trying to determine significant figures in our answer. So now we're going to discuss how to perform calculations in chemistry. And we use something called the factor unit method, or you might have heard the term dimensional analysis before. So there's 4 steps for using this method. So in step 1, we want to write down the known or given quantity. And we want to include both the numerical value and units of the quantity. And then in step 2, we want to determine the units that are needed for the unknown quantity. So in step 2, we're trying to determine which units are the desired units. So again, maybe we're trying to go from centimeters to meters, and in that instance, meters would be the desired unit. And then in step 3, we're going to multiply the known quantity by one or more factors. And those factors are going to be, for instance, the example from before where 100 centimeters is equal to 1 meter. And then we want to multiply these factors in a way so that the units of the factor cancel the units of the known quantity. And we want to end up with the units of the unknown quantity. And then in step 4, after you generate the desired units of the unknown quantity, we're going to do the necessary arithmetic to produce the final numerical answer. So it's always nice to have a list of steps for these types of problems, but Let's actually look at a problem so that we can see these steps in action. But first, I wanted to go over sources of factors first. So the factors that are used in the factor unit method are equalities. So we could also consider those as fractions derived from fixed relationships between quantities. And so those relationships could be just definitions, or they could be experimentally measured quantities. So the example I keep using is this one down here, where 100 centimeters equals 1 meter. And you can see that we're writing this in two different ways. So we're writing them as a fraction. So in the first fraction, meters is in the numerator, and then centimeters is in the denominator. And then in the second fraction, we put centimeters in the numerator, and we put meters in the denominator. So we can write this equality on the bottom as a fraction, and we can put either unit in the numerator. It really just depends on which unit we want to end up with. So for example, if we were performing a calculation, we're going to start with the given unit, and then we're going to multiply that by a factor, similar to the one above. And in this factor, we're going to put the desired unit in the numerator, and then we're going to put the given unit, or the same unit that we had in the beginning, on the denominator. And then when we multiply the units, we'll see that the given unit cancels because we have the given unit technically in the numerator and in the denominator. And then what we're left with is the desired unit. So let's look at an example. And in this example, we're going to consider a bag of jelly beans. And let's say that that bag of jelly beans contains 20 pink jelly beans. And we want to determine how many pink jelly beans are in 3 bags of jelly beans. Now, this might seem like a simple problem, but let's set this up using the factor method. Okay. So let's first write out what we're given. So we're told that 1 bag of jelly beans, and I'm going to abbreviate that as JB, contains 20 pink jelly beans. And then we're also told that we have 3 bags of jelly beans. And we want to determine how many pink jelly beans are in 3 bags of jelly beans. All right, so let's start with what we're given. So we're given 3 bags of jelly beans as our starting unit. And then we're going to set up our conversion factor here. And remember, we want to put the desired unit in the numerator. So if we look at the equality up above, we would want to end up with pink jelly beans. So we're going to put that in the numerator. And then the other part of the equality, so 1 bag of jelly beans, that's going to end up in the denominator so that it will cancel with our original unit. So now we can cancel the unit of bags of jelly beans. And our final unit will be pink jelly beans. Now, if we do the arithmetic, we end up with 3 times 20 over 1, but we'll leave the 1 out. And again, our unit is pink jelly beans. So that would equal 60 pink jelly beans. Okay, so now let's do a slightly more difficult problem. And this next problem is more similar to what we might come across in chemistry. So let's say a length of rope is measured to be 1,834 centimeters. How many meters is this? All right, so let's start by writing out what we're given. So we're told that the rope length is 1,834 centimeters. And we need to determine how many meters that is equal to. So now our plan of attack, we're going to use the factor unit method again, but we need that equality or conversion factor between centimeters and meters. Now earlier we said that there are 100 centimeters for every meter. So we can use that as our factor. So again, we're just going to start with what we're given, 1,834 centimeters, and then we'll set up our conversion factor. And looking at the equality, the desired unit is meters. So we want to put the right-hand side of this equality in the numerator. And then we want to cancel out units of centimeters. So we're going to put 100 centimeters in the denominator. Okay, so now let's make sure our units cancel appropriately. So we have our given unit of centimeters in the numerator and in the denominator, so those cancel, and we end up with meters. So when we're doing this problem, we're going to take 1,834 and divide it by 100, and then our final unit is in meters. So our final answer will be 18.34 meters. Now, these are measured values, so let's make sure that we have the correct number of sig figs here. So in the original equation, our measured value has 4 significant figures. And then we have an equality that is defined. So the fact that there are 100 centimeters for every meter is a defined quantity. So that means that both of these values are exact. And we don't have to consider them when we're determining our significant figures for the answer. So because the only number or the only measured number has 4 sig figs, that means that our final answer should also have 4 sig figs. And the way that we wrote it does give us 4 sig figs. Okay, so always take into account significant figures. And then here's the solution slide if you want to read through this later. Now the next thing we need to talk about are percentages. In chemistry, we often use percentages. For instance, we might describe a solution with a percentage. So for instance, if we have a sugar solution, maybe we describe the amount of sugar in the solution as a percentage. So it is important to know how to use percentages. Now remember that the word percentage means per 100, and it is the number of items in a group of 100 such items. So if we need to calculate a percentage, we take the part, divide it by the total, and multiply by 100. And in this equation, part represents the number of specific items included in the total number of items. So as an example, let's say that we determine that there are 20 pink jelly beans out of a total of 85 jelly beans. So if we plug this into a calculator, we would divide 20 by 85, and then we would multiply everything by 100, and we should get an answer of 23.5%. So let's go over an example calculation using percentage. Let's say that a student counts the money she has left until payday and finds that she has $36.48. Before payday, she has to pay an outstanding bill of $15.67. What percentage of her money must be used to pay the bill? Okay, so let's go over that calculation. So remember that a percent is equal to the part over the total multiplied by 100. So in this case, the part would be $15.67. And then the total amount of money that the student has is $36.48. And then we just multiply that by 100. And we would end up with a value of 42.96%. And if you would like to verify my math and just make sure that you're getting the same answer, definitely plug this into your calculator. And then here is the solution slide if you want to go over this later. And we're actually going to stop the video here. In the next video, we're going to go over a concept called density. And density is really important in chemistry. We use density a lot. So I will see you in the next video. If you would like to get a start on your homework, I definitely recommend doing that. We've covered enough material that you should be able to complete the majority of the homework assignment. But as always, let me know if you have any questions.